guys, this is silicon. Today I'm going to be doing Cambridge IGSCE Chemistry Paper 4 Theory, which is an extended paper 06/20/42 February, March 2025. So I'm going to be doing question number 6. Okay, so question number 6, it reads, the structural formula of two compounds A and B are shown. So this is A, CH2, double bond, CH, CH3. Then we have B, CH3, CH, double bond, CH, CH3. And A and B are members of the same homologous series. Give 2 reasons why the structural formula of A and B show that they are members of the same homologous series. So we want to give the reason why these members are of the same homologous series. So a homologous series, this is a family of compounds with the same general formula and chemical properties. So in this case, these two compounds, compound A and compound B, they belong to the alkene family. So they belong to the alkene family, and this is evident from the fact that they both contain a carbon-to-carbon double bond. So we can just say both have the carbon-to-carbon double bonds, like this. Another feature that you can use to identify that they are from the same homologous series is the use of a general formula. So the general formula for alkenes is CnH2n. When you say that the number of hydrogen atoms is double the number of carbon atoms. So if you had to quickly check here, this one has 1, 2, 3 carbon atoms, which is C3. Number of hydrogen atoms, we have 2 plus 1, which is 3, plus this 3, it becomes C3H6. And for this one, we have 1, 2, 3, 4 hydrogen carbon atoms, so this is C4. And hydrogen is 3 plus 1, this is 4, plus 1, this is 5, plus 3, it becomes 8. So you can see here in both cases, C3H6, the number of hydrogens is double the number of carbon atoms. Here C4H8, the number of hydrogens is double the number of carbon atoms. So we can say they obey the general formula. CnH2n, like that. The next question. Explain why A and B are both hydrocarbons. So by definition, hydrocarbons, these are compounds which have hydrogen and carbon atoms only. So we can see that both A and B, the only atoms that you can see here, it's carbon and hydrogen. So the answer is they have C and H atoms only, carbon and hydrogen atoms only. The next question, write the symbol for the equation for the complete combustion of A. So the symbol equation for the complete combustion of A, so the molecular formula for A is C3H6. So this becomes C3H6 plus O2. So combustion always include oxygen. So the complete combustion of hydrocarbons or any organic compound, it gives carbon dioxide plus water as the products. So this is liquid, this is gaseous, and this is gas. This is also gaseous. So these are the state symbols. Then we need to balance the equation. Here we have 3 atoms of carbon. So you are going to put 3 hydrogens. Here we have how many hydrogens? This is 6, and this side we have 2. So in order to balance, we are going to introduce a 3 here, so that the hydrogens are balanced. Now we have 6 hydrogens this side, 6 hydrogens this side, the carbons with 3 this side, and we have 3 carbons this other side. What about the oxygens? This side we have 2, and this side we have 3 times 2, which is 6, plus 3, which is 9. So in order to balance this, we can use a fraction and say this is 9 over 2, such that each and every atom is balanced. So in balancing these equations, you have to check each and every atom individually. Okay, so the next question, it reads, deduce the empirical formula of A. This is part D. Then part E is named the compound B. So let me refer back to the diagrams. So compound A, this is our compound A, and we are required to deduce the empirical formula of compound A. So already we know that the molecular formula of compound A is C3H6. So the molecular formula shows all the atoms which are present in a compound, the actual number of atoms present in a compound. However, the empirical formula, this is the simplest whole number ratio of atoms in a compound. Yes, so in order to simplify this ratio, just look at the highest common factor. So the highest common factor for 3 and 6, that is 3. So if you divide 3 by 3, it becomes 1, so we're just going to write C. And if you divide 6 by 2 by 3, it is going to become 2. So the empirical formula for compound A is CH2. If it was for compound B is C4H8, and if you divide by 4 both sides, it becomes CH2 again. So the empirical formula for alkenes is always CH2. Why? Because from our general formula, we said the number of hydrogen atoms is always double the number of carbon atoms. Then the other part of the question required us to name compound B. So compound B, if you have to name compound B, this is an alkene. So the prefix, the suffix, which is the last part of the name, it ends in ene. And the prefix, the first part of the name, indicates the number of carbon atoms. So here we have 1, 2, 3, 4 carbon atoms. So this is but. And we also need to indicate the position of the double bond. So the double bond here is between carbon number 2 and carbon number 3. So since it is between carbon number 2 and number 3, we choose the smallest number and it becomes but 2e. The next question, it reads, a structural isomer of B is a member of the same homologous series. Draw the displayed formula of this structural isomer. So we also need to define what an isomer is. So an isomer, so these are compounds of the same molecular formula, but different structural formula. So this is the definition of isomers. They have the same molecular formula, but they have different structural formula. So compound B is CH3, CH, double bond, CH, CH3. This is compound compound B. So the molecular formula for this is C4H8, as we discussed earlier on. C4H8, C4H8. So the isomer for this must also have the same molecular formula, which is C4H8, but what has to be different is the structural formula. So what we can do here is just to move this double bond such that it becomes CH, double bond, CH, CH2. So this also has to be how many? One hydrogen, one bond, 2, 3. So it has to be 4 bonds around each carbon. So this is CH2. Then this should be CH. This should be CH. It has 2, 3, and then this is CH2, and then CH3. So this is the isomer. It is 1, 2, 3, 4 carbon atoms, and 2, 3, 5, 8 hydrogen atoms. So the molecular formula is still the same. So this is but 1-ene. This is the name because it is on carbon number 1. The double bond is on carbon number 1 and carbon number 2. However, the question required us to draw the displayed formula, meaning to say that we're going to show all the bonds. So this is like this. The first carbon is 2 hydrogens, so I'm going to put 2 hydrogens. The second one has 1 hydrogen. Then we continue this one. It has 2 hydrogens like this. The last one has 3 hydrogens. So take note that the maximum bonds around each carbon atom is 4. So this carbon atom is 1, 2, 3, 4 bonds. This one it is 1, 2, 3, 4 bonds. This one 1, 2, 3, 4 bonds. And this one 1, 2, 3, 4 bonds. Part G. Part G. The question reads: compound B reacts with aqueous bromine at room temperature to form product C. The equation is shown. So this is our compound B, which is but2-ene reacting with bromine to form this compound C. State why this is an addition reaction. So this is an addition reaction because only one product is formed. So in an addition reaction, we have a large molecule reacting with a smaller molecule, and that smaller molecule is added onto this large molecule or this larger compound. For example, here bromine is being added across the carbon to carbon double bond. So one of the bromine atom attaches to this carbon, the other one attaches to this carbon. So you can see here the second carbon has the bromine and the third carbon has this bromine like this. Item 2, describe the color change in aqueous bromine during this reaction. So the color change in aqueous bromine during this reaction, it changes from orange to colorless. So this is the color change. When bromine is in aqueous form existing as Br2, it has an orange color. And when it is used up in a reaction, that orange color of Br2 molecule is decolorized, so it changes from orange to colorless. Then item 3, it says name product C. So we want to name this product. So this product, maybe we can use the display for us to easily identify or understand what is happening here. So this is how this compound looks like. If we were to draw the displayed structure, so you can see we have 3 hydrogens on the first carbon and hydrogen and bromine on the second carbon, then hydrogen and bromine on the third carbon, so this is Br, and CH3 on the last carbon. So if you had to count from either side, let's start from this side. This is carbon number 1, number 2, number 3, and this is number 4. From this side, this is carbon number 1, number 2, and number 3, and this is carbon number 4. So you see from either direction, this becomes carbon number 2, and this is carbon number 3. And this is number 2, and this becomes carbon number 3. So the carbons with the bromine atom are always carbon number 2 and 3. So in order to name this, you identify the main chain. The main chain is 1, 2, 3, 4 carbon atoms. So this is known as butane. So why is it called butane? Because it is now a saturated compound, so it is a derivative of an alkane. However, since in this butane molecule we have 2 bromine atoms, we have to account for that in our name. So we also indicated the position or the number of the carbon number to which they are attached. So the first one is attached in carbon number 2, the other one is attached in carbon number 3, and we separate numbers and letters with a dash. So this becomes 2, 3, and since there are 2 of them, we use the term di. Di means 2 in science. So this is di bromobutane. So the final name becomes 2, 3 dibromobutane. So this is an example of a dibromoalkane. So the name of the product is 2, 3 dibromobutane, like this. So the last part of our question, part H, the question reads, under certain condition, 1 mole of B reacts with oxygen to form 2 moles of a carboxylic acid. Carboxylic acid D has 2 carbon atoms. Draw the displayed formula of carboxylic acid D. So a carboxylic acid with 2 carbon atoms. Let us first of all draw the 2 carbon atoms. So the carboxylic acids, their functional group is the COOH. This is the functional group for carboxylic acid. So the carbon atom in the functional group is also included in the total number of carbon atoms. So this is the carbon with the functional group. So the displayed formula look like this. This carbon is 1, 2, 3, 4 bonds. And I'm going to add hydrogens on this side so that this carbon is 1, 2, 3, 4 bonds. Then item 2, it says name the carboxylic acid D. So the carboxylic acid D, which has 2 carbon atoms, the name is to indicate that it has 2 carbon atoms on the first part. So the prefix for a compound with 2 carbon atoms is F, and since it is a carboxylic acid, the name should end in anoic acid. So this is the prefix for carboxylic acid. So all in all, it becomes ethanoic acid. So the name is ethanoic acid. So the last part, item 3, complete the symbol equation for this reaction. So the symbol equation for this reaction, since we are told that it reacts with oxygen, we are going to put oxygen here, this is O2, and it forms ethanoic acid, which is CH3, COOH. And if you are, so to balance this equation, you can see that on the left hand side we have 1, 2, 3, 4 carbon atoms, and on the right side we have 1, 2 carbon atoms. So we can multiply by 2 such that we balance the number of carbon atoms. So now we have 1, 2 carbon atoms, and times 2, this becomes 4. So they are now equal number of carbon atoms on the right and on the left. Then when you introduce these 2, we have 2 oxygen atoms here. If you multiply by 2, it becomes 4 oxygen atoms. On the left we have 2. So to balance, we also put a 2 this side. Let us also check for hydrogen atoms if they are also balanced. On the left side we have 3 plus 1, which is 4 plus 1, 5 plus these 3 becomes 8. And on the right side we have 3 plus 1 on the molecule of ethanoic acid. So if we say 3 plus 1, this is 4, multiplied by 2, we have a total of 8 hydrogen atoms on the right hand side, which is equal to the number of hydrogen atoms on the left hand side. So once again, when you are balancing equations, you should check each and every atom individually, one by one, to check if they are balanced. So ladies and gentlemen, we've come to the end of this question. Stay tuned and don't forget to like, share and subscribe.